Hey there guys, welcome back to my channel. So in today's video, we are going to see an attendance system which is operated facially, and in this what we have to do is first click on capture.py. So this will capture some photo samples, and one more thing, in this video I will also tell you all the fixes which you need, and I have even more fixes, and I have also created requirements file. And here what I will do is go here to capture.py, and if I run it, so here in the console what it will do is ask for the client's name. So let it load quickly. So in the client's name I will type and after we have typed the client's name, then we have to click here enter, and this window will pop up. So here what I will do is just create some photo samples. So it will do this till it is 100, and so I will let it happen. So it's on 74, so like that what it will do is capture this till 100. So once it is 100, the window will close. So as you can see in the images folder, there are 100 photo samples, and this is the user index 1 right over there. And then what we have to just do is go here to train.py. So inside this, what it will just do is train those image. And so if I just show you quickly, so it will just train my images. And after it is trained, it will show training data set completed. So what this will do is created an ATT system classifier. So next what we will just do is go to main.py, and here if I run it, then what will happen that it will start getting attendance in my attendance.xls folder. So let it quickly load. So it automatically captures all the attendance. So as you can see, and it will also capture the date and time. If I open the Excel file right over here, then you can see that it is my name and there is the date, as you can see, and the time has also captured. So like this you can capture attendance in this Excel file. And now let's see how to make this thing. So to start, I will start from the files. So first we will start from capture.py. So let's see what's here to start. So here we have an Excel file, and the fixes in which what you can just do, if you get any error throughout the video, then you can just run this command, and still the error is not being solved, then what you can just do is say here pip and install OpenCV contrib, this thing here. So you can just run this command. If even using this command the error is not solved, and then again use these two commands here. So if the error is not solving, just use these commands. So these two are error fixes if you get them, and the requirements are these files. So if I really quick show you, so here the requirements are, so I will just type here. So these are the requirements here, so which are OpenCV, Python, Pandas, XLS Writer, XLRD. So XLS Writer and XLRD means Excel file read and Excel file write, and this is the writing engine for the Pandas. And here, so first we will start from the capture.py. So here in capture.py we will first start by importing files. So we will need CV2. For starting, we will type the basic CV code quickly. So cap video capture. So cv2.video capture, and here the camera index, which is 0 if you are using another camera. If you have two cameras connected, then if you are getting the view from first camera, then you can use one. And then next thing is while loop. So while true, so it will run forever. And here we'll say underscore image, and here we'll say cap.read. So underscore is used when we don't want to store it and don't want to use it, then you can just type underscore. And once we have our image frame by frames, then what you can just do is say here cv2. So here I will just say here key equals to cv2.wait key, and here I will type 1. And next, so 1 will be the order of the frame, so it will be 1 milliseconds delay in all the frames of the camera, so it is normal. And here we will say if key equals to 113. So here 113 means the key Q, then we will exit it by using the break. So what will break do is come out of this for loop and end the program because there is nothing. And here one more thing before it. So here we'll say cv2.ImShow. So what ImShow will do is it will open a window in which it will show us. So ImShow, here we have to type the name of the window. So here we'll tap capturing photo samples, and here I will specify the image. So if I quickly run this out, then what will happen? So let it load quickly. Okay, so as you can see me, I am here on this camera. So if we press Q, it closes. So this is the basic CV2 code which we are using. So what I will have to create now is an face detector. So to do that, I will use this basic cascade image XML file. So this cascade XML file name, just copy it. So don't worry, all these files you will get in my GitHub page. And here just say here face cascade equals to cv2.cascade. And here inside this just write its name. So this will initialize it, and just below here you can say here cv2 face cascade dot detect multi scale. So inside this what we have to pass is a grayscale image. So to do that we have to say here cv2.cvd color. Inside this pass our image or the thing which we want to convert, and see here cv2 dot color underscore bgr to gray. So here we have it. So then once it is connected, what I will just do inside this, I will pass the grayscale image which we have, and then after the grayscale image I will pass the values which I need. So in this case you can experiment it with those. So if you're not getting an accurate and proper result, so you can just mess with them. So the lighting also differs. So at morning mine was 2.2 and at day it is 1.8. Then the minimum neighbors. So here I will type 5. And next, after getting the detection, what I will just do is store this in a variable. I will call this spaces. So once this is in a variable, what we can just do is come down here and run a for loop for face in faces, and what I will just do, this will give us a face of means item in it, and or also you can say here x, y, and height and width. You can use them both, but this will give us these values separately. So inside this, after getting these values, then what we can just do is here, you can see here cv2 dot rectangle, and we will draw a rectangle on our face. So just to show that it is detecting, I will say here image, and then what I will just say here the location, which is x and y, and then the part, then the width and height. So here what I will say here, x plus width and y plus height. So this will give us the result, which is the exactly scale which we want, and then the color, which will be blue. So I will say 0.255, and then the thickness. So let's keep the thickness around somewhat 2, and then save it. So if I run this, so let's see what happens. So here it is. So it's not detecting it properly, but it's detecting. So as I said, mess up with these values. So if I just exit it, maybe I could get an accurate result if I change these values a bit. And one more thing, that after doing this rectangle, what we have to do is just crop the image and save it in the images folder. So as you can see, it is a bit accurate than that. So you can just mess like that, but I will do it later, not now. So here I will just go here down, and here I will crop it. So to crop it, I will say a face crop equals to image. So we will take the image, and then what we have to just do, if you don't know how to crop from the xy, so to crop that we need the x and the x plus width, and then I messed up the sequence. So here before it we need y by y plus height. So this will crop the image. So if I also show you this cv2.im show, and here I will say image and face crop. So if I run this quickly, so it gives an error that face crop is not defined. So why it is? Because we need the parameters in the for loop. I did a very much silly mistake. So if I do it now, so here it is. So let it detect. So as you can see, once it detects, it just shows the photo. So what I will just do is I will replace this face. I will say here gray for the face crop, and here I will say gray underscore face equals to, I will say here cvt color, cv2.cvt color, and inside this I will pass the face crop, and the code will be cv2.color underscore pgr to green. There we go. And then just below it we will have to save it. So before saving it, we also need the image ID, as you know. So what is image ID? The number of the images. So here we'll just say image ID, and here I will set this to 0, and just below it I will say here image underscore ID equal plus equals to 1. So this is the compressed text increment statement, and we also need the number of images which we have saved before. So how we can get it? How we can get the number of users which are saving in it? So to do that, what we have to do, so this is a bit adjusting kind of thing which I have done here. So it is for IDs underscore, and here underscore, which is the values in the enumerate of of the items in this. So how we can get the items with the OS? So what OS dot list dir. So this gives us list of directories. So I will just quickly include this with the quick fix. Okay. So then here what I will just do, list the directory. Then we have to give the name of the directory, which is images. So this directory. So how much files are in it? So once we have captured photo samples of one client, then what will happen? That there will be 100 photos, you know. So then here we'll say if IDs are greater than less than symbol, means the IDs should be greater than 100. Then only what I will just do, say here IDs equals to integer of the IDs, and I will divide this by 100. So and I will add here 1. So what it will just do, if there are 100 photo samples, if we divide 100 by 100, then it will give us 0 plus 1 is 1. If there are 200 photo samples, means 2. If divided by 100 plus 1 means 3. And similarly, it just works like it. And you know that thing. So here, one more. If I come out, I will say here if the image index, so one more thing, that just say here image index equals to IDs, just like that. And then I will say here image index is equals to 0, means there are no files in it. Then what we can do is come here inside it and say here image index plus equals to 1. So plus equals to 1 will just add 1, means the value of 0 plus 1 is 1 only. And then if I come here and I have my image ID and the image index which I needed, then here just come below it, and here what I will just do before that, I will just resize the grayscale image face equals to gray face dot resize, and I will resize it to 450 by 450. So once the image is at an appropriate size, then what we can just do is, so I just did a mistake here. So that is a silly mistake here. So just here and here we'll specify the gray scale image. So instead of specifying here CV2, I specified gray, and here I want the face. So once the image is resized, what we have to just do is get the path and save it. So what will be the path? So here the path will be the images directory which we have here. So images plus the name of the person. So here I will ask for an input. Name equals to input, and here we'll say client name. So let me just mark in double quotations, and here I will say images plus the name of the person plus dot and plus the image index, means how many users are registered in it. So here I will specify plus image index. So either in adding this plus plus statement, one more short trick if you don't know, which I will use, is the F string. So here I will say here first the images directory, then I will code this and I will say here name, and here dot, and again this, and here I will say the path. So here I will say here image index, so number of users, and then dot, and then we need the image IDs. So image ID, and one more thing, that just ensure that these are integers and then convert these to strings so it can be text. So str, and I will do the same thing. So these values will maybe also sometimes decimal. So when I tried out, the image index was decimal. So that's why what we can just do is ensure by converting into an integer. So then we have the address. So here in the address, what we can just do outside this, I will also add one more thing, which is .jpg extension. So after this, we have the path, then we will come down, and after we have the path, here we will say cv2.im write. So what this will just do is write the files in the directory. So here file name and means the path will be specified here, right over here, and then the face which we have, and nothing else. So that's it. So simple as that. And next here I will say cv2.putText. Inside this we have to also show the number of registries. So inside this I will say put text, and here I will specify image, and then I will specify the image ID. Then I will specify the location, which is our 50 by 50. So it will be on the topmost corner, just a bit spacing, and then font will be cv2.font Hershey complex, and the font scale will be 2, and the color will be blue, so 02550, and then the thickness will be also 2, and then the line type will be cv2.line underscore. So this is not necessary to give, but I like to give it. So then just below it, we will just do is display the output which we have done here, and then after drawing the things, we have to also do one more thing here. Say here, or the image ID is equals to 100, means as it reaches 100 photo samples delete, means stop them. So once we have done all these things, so we can just test it out. So let's quickly take our photo samples. So let it load because we have typed a lot of code. Okay. So here it asks for client name. Here I will specify it, and then it shows an error that image index is not defined. How can you do that? It says, and then here we'll just say image index is equals to 0. So what logic we are applying in this, if you're still confused, that if the IDs are greater than the minimum IDs, which are, so maximum IDs are 100, means there are more than the 99 IDs, means there are 100, and so on, but not 0, then what it will just do is divide it. So if we divide 0 by 100, so it will be a mathematical error, then it will calculate it. And here, as you remember, the image index is by default 0. Then what I will just do is say here image index is equals to 0, then add 1. So as simple as it is. Then now if I run it, it should fix the error. So client name, I will again specify it. So if I run it now, so let it detect my face. So as you can see, it is showing here. So one more mistake which I did while saying that here the color is sequence is like RGB, and I just accidentally put it in here. So that's my mistake. Sorry for that. But green also still looks okay. So there we have our 100 photo samples. So as you can see, the sequence is correct. So let's minimize it. So now we have completed our capture. We have our photo samples. Then as we have seen in the demo, what we have to just do is train the cascade file. So the method which we are using here is called LBPH, local binary pattern, or local binary pattern histogram. So if I just search here for LBPH, here we have LBPH. So inside just scroll down. So what method which we are using is here the image pixels, which are converted into the threshold value, then into binary, which is the method which we will use here. So if I just scroll a bit down, yes, so here the steps what we will see here. So training algorithm. So first we will train the cascade here in this method, and before doing that we will also turn this into grid X and grid Y, and then we will train the cascade. Then we will apply the LBPH operation, which is, so don't worry about all these things below because it will be as easy as using the cascade. So just they are explaining that how the cascade is work. Don't worry about it. And then, so let's start using it. So first, let me just quickly write my imports. So import CV2, and for turning the image into grids, I will also use numpy has np, and I will also import C types for the message box. So including C types is not that necessary. And then just below it I will import the pillow. So I will import PIL. So this is known as pillow. And here I will import from PIL, import image, and then just below it I will import OS. So as you have seen, the OS uses to list directory here also. So after writing the imports, here I will say and define train classifier. So train classifier, and inside this I will only ask for the data directory, which is our image. So here this directory I will ask for, and just below it I will get the path. So here the path will be, I will just do a compressed statement here. I will say here for loop. So here I will say for, so for file in os.list directory. So it will give us all the name of files in it. So this directory we will perform this on data directory, which we have here. And then once it is performed, then what we will just get the name of all the files one by one in the for loop. So inside this, one more thing which we have to do, just come here back and say here os.join, and here in this join statement what I will just specify is the path, means this thing only. So I will just remove this dot and os.path.join, and here will specify my data directory, and I will specify the file which we are getting in this for loop. So just like that we have created a compressed for loop. So if you are new to this, so don't worry. So what we have to just use a write for loop statement, and what we have to get here inside it. Then come down once we have the paths. Then just come here, and I will also make an blank list of pieces and IDs which we will require later, and here we'll say for image in path. So it will give us the what we say, the path one by one inside it. So there is more lists in it, and inside this what I will just do, so we have the image address, and I will say here image equals to image from the PIL library below, and here we say image dot open, and what we will open is these images from here. So it is a huge library, right? So with it we will create and cascade from it. So here say image dot open, and inside it we have to pass the image which we have, means the image address, exactly which image. So it will give us one by one images. So once you have done that, come down, and just here we will say so one more thing there is one more compressed statement for converting it in PIL library. So you may not know it. So to convert this in grayscale, what we can just do is say a dot convert, and here specify L as the mode. So what this will just do, this is just a statement for converting this into grayscale. So once we have this in grayscale, what I will just do is say here image np. So this will just give us the grid, the image in grids, as I said. So say here image np equals to np.array, and inside np.array, so it is just an specifying type in numpy to say as a grid. So just understand like it, and say here image which we have, and specify the d type as uint 8. So what is this uint 8? It is just an encoding type used in the NumPy library. So I will just say it, and then after we have the grids, then we will get the ID as you remember. So for doing it we will need an ID. Then after that we will append in this spaces list and then just we will just append IDs and we will just start training the images. So here I will say here ID equals to integer. We will convert this into integer, which is image dot split. So here we'll say split. So split, what the split does is if we have this name inside it, so it will just split it text, the text which we have in it. So if we have capture.py, I will split here dot. So what it will just do is give us a list which is splitted into this without this dot. So in this list, which element we want to access. So in our case, the ID is 1, means this, the user number of it. And then just come below. So for converting into the thing which we want, the cascade which is created from the LBPH. So to do that, we also need the ID. So that's why we have done this. So then say your ID integer after we have all that done. So just append all these things in the lists. So append face. So faces dot append image np. So there are many image nps like the grid which I told you. So then we will append the IDs dot append, and inside this I will append my ID. So after this we also have to show the training progress, right? So to show the training progress, say here I am show and say here training, and here I will specify the image np. So the grid images, and say here cv2 dot wait key 1. So it gives an switching between it, so it will not be stuck, it will keep switching. And here we'll say just out of the for loop, I will say here IDs equals to np dot array. So to specify in the encoding of the cascade, we have to also specify the np dot array. So we will just convert it. We are not doing anything here, we are just converting in the numpy format. So here I will say IDs. So it's nothing to be confused in it. So here what we will just do is train and save the classifier. So first we will do the training progress. So I will just comment it training, and inside the training here we will create a variable called clf cv2 dot face dot. So just remember that the VS Code doesn't give the things for us in some libraries. So after doing this thing, you may get an error. So you will have to run this for sure, and you can run this. If this doesn't fix, run this commands. So here say cv2 dot face dot, and here say here LBPH face recognizer. So this is the LBPH formula given from CV2. So say here create. So what it will just do is create an template classifier for us, and then we will have to train it. So clf.train. So from what things we have to train, as you remember these things. So as you can, what the training does it just gets the threshold here from we have it, and then it will just convert it into binary as we have seen here, this thing which is happening from this train. So here I will say here train, and inside this I will specify the faces and the IDs. So it will train it one by one. So remember why I have done this, I was telling you. So then after the training we have to save it. So I will just comment it here. So for saving, what I have to just do is say here saving and clf.write, and here after writing, here we have to also specify the file name. So the file name is So the file name here I will name it as att classifier.xml. So it is this extension used for classifiers. And then come down and then just do a bit of cleaning up. So I will just clean up by saying cv2 dot destroy all windows. So I don't usually use this, but just doing for cleaning up progress, I will doing it. Then I will show the message box as you remember. So here I will say ctypes.windll user32 means it will be for 32-bit, and 32-bit things can be also used at 64-bit user. So this PC is 64-bit, but still it will work for me. And then here say here message box. So message box W, and W stands for Windows. So here specify 0, and then I will specify the thing for the text which I want. So training completed, I will say here training completed, and the title of the window will be result, and then specify here one for the cancel and the type of the message box. And then if I run this, so this will quickly train it. So why this is not happening, right? So this is because I haven't called it yet. So I have to also call this function which we have made. So I will just say here train classifier, and I will just call it. So data directory is images here which we have. So in this all the data is present. So now if I run it, so you will see all the trading progresses. So it showed trading completed. We will say here okay, and as you can see we have our classifier. So now we have also trained it and capture samples. So after capturing samples we have trained, and then now we have to do the main face detection part. So to do this will be really quick, very simple, but just it is a bit complicated. Just a bit, not that much. So I will import here OS. So as you know, we need it everywhere for getting our files, cv2, and then I will import numpy. So after importing the imports, I will say here recognizer equals to, I will say here cv2 dot face and dot LBPH, and I will say I will create the recognizer face recognizer, and I will say here create. So here what we have done is saved this. So what you will be thinking that why we are creating it again. So here what we are doing is not creating the file again. So here we are doing is we are reading the file, the classifier which we have created before. So here to do that I will say here recognizer dot read. You can also say this CLF for classifier, and here I will specify the att classifier dot xml. So this is very much simple for now. So cascade classifier, and the cascade classifier to create it will be as usual. So here I will say here, so let's call it face classifier. So it is for face detection, or you will get confused. And here say here cv2 dot cascade classifier, and inside this which classifier. So this is our normal face detection one. So because it will also detect the unknowns, and here after doing it, if we will just come down and we will start getting our path. But before that as you remember, we will also define our ID because we will need it, as you know, for what which we have done in training. So here we have used it for doing the training progress. So train IDs which we have used here. So similarly, after copying for getting the prediction, we have to also use it. So here I will get that, and just below it I will say here path equals to the same thing which we have done. So I will just quickly copy it. I will just paste it here, and I will replace the data directory by the images directory. So once we have done this, come here, just down and say here names equals to a blank list, and here say for image in path. So inside this for image in path, what I will just do is say here name equals to image. So what I will just do, the get the name by splitting it. So here I will split it and get the first element. So I will say a name equals to image dot split, and here I will say a dot, and which element which we want is the first element as it is our name. And then here just below it, what I will just do is I will also say here name. So I just messed up a bit. So I will say a name, because in this name what will happen that here the images address will also come, as you remember. It will come like images / Techno Kidzo, and so we have to also prevent it. So I will say here name equals to name dot split, and here we'll specify the /, so we can just prevent the images, the address of the directory to be seen from here. So we have our name here, then I will say here names dot append our name. So we will get all the names which we have here. So we have to also prevent from getting 100 items in the list. That will be so much shocking. So to prevent it, what we have here is something called as set. So how we can use it? So here just say here names equals to set, and say here names. So what set does that it converts it into a dictionary. So while converting into a dictionary, it also removes the duplicate items in it. So we will get hundreds of duplicates here, and we will also get more hundreds if we have one more user here. I've just added one for now, and inside this code this into a brackets and convert this into a list. So what will happen that the dictionary will be converted into a list, and then for just cross-checking I will say here print names. So you can see what happens. So it shows one name in the list. Then just below I will create and capture. So I will say cv2 dot video capture, and camera index is 0. So I will just create some space here really quick. See a while true, and while true, inside this, as you know, we have to get our image, the things which we want, and here cap.read. So this is as usual what we do in the basic CV2 code, and here we have to say get the gray image for detecting. So again what we have to just do is do the same thing which we have done here. So I will also copy it from here because we have already done it. So here I have named it face classifier. So I will see here face classifier dot so the face classifier dot the cascade which we have, and we also have our recognizer. So after we have done the classifier detecting, so that all stuff, then we will just come here down and then what I will just do is here will run and for loop. We do as always, so I can even see your face and accesses one by one. But this one is easy way, so that's why I'm doing it. So faces all the regular stuff we have done. So CV2 dot rectangle. So we will again get the face recognition which we have done. So we know it works. So just before doing this, I also remembered that I forgot adding the wait key, CV2 dot wait key 1, and if this is equals to 113 means Q, then we will break the for loop which will exit this. So we will just break it, and inside this rectangle we will again concentrate here. So we will draw this rectangle on image, and the location means the top left corner location of the rectangle. So here it will be the x and y. Just put this in and double, and then the width and height. So we also want it with originating the x and y. So we will just add x plus width and y plus height, and then the color. So I will specify here the color as green. So here I've done it, and then the thickness I will set it as 2, and then I will get, after that I will get the ID and my confidence by the recognizer. So you remember that we have done this exportation and we have again repeated it by reading it. So after reading it here, we will use it here. So I will say here recognizer dot predict. So as I told you before, we will also need the ID here. So say here in brackets of the predict, say here gray. So we will also require the grayscale image. So I will just convert it according to the cropped image. So this cropped image, as you remember, and then we will just compare it. So here I will say x, y, and I just did wrong sequence, and x, y by y plus height, and x by x plus width. Something like that we have cropped like we have done before. And after we have done the predictions, what I will just do is print here an ID. So as you remember, this ID we have defined it before only. So because the definition will not go wrong because of it. So once we have our ID means this number, so it should be matching with it. So here what I will just do is either I will just not print it, and I will say here if the confidence is okay, means if the confidence is less than or greater than 100, then we will just find the perfect match. If the confidence is less than or is greater than or equals to anything like somewhere close to the 100% or something close to it, then we will do our thing. So I will just put it in brackets so it will be easier to understand. So here we will get our perfect match which we need, right? Here we say ID equals to names. So this is again a bit code style in my language. So it is not ID, it is actually name, but still I like it to specify like it. Then I will say name ID minus 1. So what it will just do, the ID which we have in 1, 2, 3, 4, 5, 6 like that sequence. So we were in list we have to just decrease the index by 1 because the index goes like this 0, 1, 2, 3, 4. till, so that's why I'm subtracting 1. Then I will see here confidence equals to an string. So in this, what I will just do is say here, so I will use the S string. So inside that I will add in bracket and 0%. So what percentage will the confidence be? So for the F string, it is one more short, a bit similar to like that. So here we can also use dot format here, and I will just round it up because it will be a decimal value. You can also use the integer conversion like I have done before. So I'm just trying to show you different methods which we can do. And here say here 100 minus our confidence, right? So this will give us the confidence in the text which we will show. And then after we have our confidence, come down and here say here else. If we don't have a perfect match, then what I will just do, so what we need is a perfect match, right? So if it is not, if it is an unknown, then I will print here text as unknown. So ID is name, just remember it. And then similarly we will also get the confidence by the same method. And so we have the confidence on both the sides, which is as same as it is. And after that, one more thing which I will do is just come here and I will say cv2.putText. I will display the text with the name. So to do that, what I will just do is say here put text, and I will need to put it on image, and the text will be the ID, means the name, and then the location. So one more thing that I will just ensure that this is string, and then just below it I will add, let's us indent it properly so we won't, so it will be displayed properly. So that's why I was saying it. So then what we can do is say here inside the location x plus 5 and then y minus 5. So it will be a bit distance there. So what will happen, that it will just be in center because it is the top left corner, right? And the y minus 1, so it will not overlap, it will be just a bit upwards. So what I am trying to say is this, and then I will specify the font. So inside the font will be cv2.font Hershey complex, and then just below it I have to specify the font scale. So I will scale it as 1, and then the color, so let's keep this as white, 255, 255 and 255, and then the thickness will be 2. So I'm just keeping a bit smaller font size. So here what I am going to do is add an if statement that if the ID means the name, as you know, is not equals to unknown, means the person which it is detecting is not unknown. So right over here, let me quickly type it out, and then it should add an Excel file which is attendance, as you remembered, and let me just change the U to capital letter. So just remember that the casing is similar as it is sensitive casing for it. So here I will type import, and so here what we will use is pandas module as PD. So pandas will help us to write the Excel file, and I will then write from. So one more thing, that if I quickly open the Excel file, then you can see here that the date time which is there, So to get that, what I will do is use a module named datetime. So from that I will import date and datetime. So what will happen that we can use them both to get our date and time, something like that. So I will clear those values so they will not get repeated after the. So in the actual project you don't have to remove the values daily, so it's not required. So here from date time import date and date time. So there we have it. So as I told you, so from date and time we will be getting our date time. So here I will say, so one more thing, that if I go to requirements, as you can see these three modules which I have, you will say that, hey, why we have installed these, but we are also not even importing those. So pandas uses them as a dependency for writing engine, if you don't know. So that's why I'm using those, and say here time now equals to, so here I will say time now equals to date time dot now. So this will give us the current date and time. So how we can filter it? So to filter it, I will create here a variable called current time, and inside this I will say here time now dot strf time. So this is used to filter the times. So percent h for hours, percent m for minutes, and percent s for seconds. So here we have to specify it as a string. So s string f string time. So that's why we have to specify the percentage. So if you have done other languages, then you must have understood it. So let me quickly type it out. So there we have it. So now after it, what I will just type is, quickly I will type it out. So I will say here, just a second. So here I will go to my Excel file, and just remember that, just always remember naming the sheet and the file name as attendance, or it will give an error. So I will say here df underscore old. So why we are doing this? Because what should happen, that the old data in the Excel file will get replaced when we directly create, and data frame means it is an, you can say, a dictionary type of thing in pandas. So as you can see, I am creating it. So but here what I have to just do, I messed up. I have to say here read Excel. So it will read that Excel file and return me the data frame. So from that data frame I can append the data which we have. So the data frame which we want to add, I will just append it. So and finally we will save it. So let me quickly type it out. So always remember that the extension should be for Excel file XLSX, or you can also use CSV if you want. So as I told, just the sheet name should be same, because or else it will give us error. Sheet and file name should never be not same as the file which you have. So then after that I will create the data frame as I told you. So I will say here data frame equals to pd dot data frame. So and inside this we have to specify an dictionary of data, so which will get appended in our Excel file. So let me just type really quick, type the data. So in that you can also type and tuple, and as you were able to see in the screen before. So then inside this I have to type a string name. So if you don't know dictionary, then just quickly see the format. So while creating the variable, just remember all the variables here should be in list format, or else it will give an error. So for here I will say here strid. I will just ensure that the strid means the name is as same as the string data type. So then next I will say here date, and inside that remember how to get the date. So you may have used it, so here I will use the date so the date from the date time which I have imported. So I will say str date dot, so let me just quickly type it out, date dot today. So it will give us the date. So then next I will return time. So let's type here time, T capital, time, and then colon. So the argument is the variable which we created for storing the time, and that's it. So what this will just do is create a data frame for us so we can just store it. So data frame just is a format used by pandas, so don't get a lot confused by it. So next thing we have to append the data into it. So see here data frame equals to, so why we are saying here the data frame equals to, so this is because I have to append the data. So df underscore old dot append. So why we are appending it, because the old data should come first and the new data should come after, right? We can also do data frame dot append df dot old, data frame dot append df dot old. So the new data will be placed on top of the old data. So in this sequence it will return the old data on top of the new data. So here pd.excel writer, so name of the file, so it will overwrite it. It so if you haven't created the file, it will give an error. So engine equals to, so remember why we installed those requirements, so those were as an engine writer for the pandas. So engine equals to, so there are many engine in pandas also, but in this case I am using XLSX writer. You can use any of these, you can just Google them. Then data frame dot to Excel, so this is because of I am doing this to export the data. So to export the data we use to Excel. So I was just closing my Excel file, so that what will happen, that it will not get error while accessing it if you don't know. So then in the to Excel, what I will just quickly type is the writer. So here I have not created, so the writer, so what's the writer? So the writer is the pd.excel writer, which I will quickly type it out. So I just forgot to create it into a variable. So what will happen, that it will return the Excel writer type of the thing which we want, and then we can just specify here the writer. So writer is nothing but a thing which is initialized with the engine, and it knows that we have to access that file. So I will store this in writer, and then next what I will just do is inside the data frame to Excel, I will give it the data which we want. So next here we need the sheet name. So the sheet name here will be, so the VS code is not giving the autocorrect, so that's why I got a bit confused. So then sheet name equals to, so here the sheet name, so as I told you to pass the arguments as you have in your Excel. If you don't want to pass the same arguments, you can change it, that's not a problem. Then here next thing is the index equals to false. So why we are using this index equals to false? So the main approach in using that was that we will have to specify the index at 0, 1 and 2. So like that, what happens if there is an old data, we will not know the index of it. So we may encounter an issue of overwriting or anything else. So I was not making it too complicated and just doing it like that. And lastly, say here writer.save. So what it will just do is uh, do a bit of cleaning up stuff. And next I will show the our window. As you remember, I just remembered it now. So I will see here I am show camera and I will pass our image. So here we go. And then lastly, what I will just do quickly is, last but not the least, I will scroll down and do a bit of cleaning up stuff. So let's print here a text for it. Cleaning up, exiting and cleaning up. So let me quickly type it out. Exiting and cleaning up stuff. So let's type like that. And then next what I will just do is say a cv2 dot destroy windows and I will release the capture. So what this does is just optimize this a bit. So later it will just clear the data. So you won't face a problem. So I will say here cap dot release. So there we go. So now we have completed our main.py. So let's quickly test it out. So again it will take some time to load. I know it's a bit slow because of I am also doing my 60K recording and the 60 FPS recording is also affecting it, and 60 FPS recording is also a bit looks a bit nicer, and the recording which I am all doing is also 4K, so it gets more effect on the PC. So that's why what I will just do is, so one more thing that those so what I am doing is, this is the right way to learn. So in this what I am just doing and using is the CV2 and the LBPH algorithm. So this will give us the most accurate result. And if you don't know that, this is just there are also some modules on the internet, but the modules which are on the internet will not let you know what they are doing. That's it for today's tutorial and thanks for watching.